Okay, guys, welcome back. It's already 5 minutes past, and we really want to get started, so we're not late in the end. I hope you all had a great lunch. Some of the good fish that they have here, it was awesome for me. The first speaker we have this afternoon is Tim Pozar, who's going to talk about, I have to look it up, I'm sorry. The connections and politics of a municipal, I can't say that, network. He will say it probably, I'm sure. Welcome, Tim.
Thank you. Hi, guys. Oh, I'm supposed to have a clicker or something? Or?
Great.
Ah, great. Thank you. Excellent. And the time keeps going up. Great. Thank you. My name is Tim Pozar. You've probably seen me occasionally show up to these things, either give talks or drink beer at the Beer and Gear. Of late, I wanted to sort of talk about a sort of grassroots project that we've done at the city of San Francisco, much unknown to most of San Francisco and much unknown to much of the city government. This is actually somewhat of a grassroots thing that we did with like zero money and big impact, and I wanted to sort of cover how we did that and how we sort of got around a lot of the politics of San Francisco to do that. Quickie, a little background. There was in about 2006, there was this bright idea by Mayor Gavin Newsom, who is now our Lieutenant Governor in the state of California, to do this blanket of Wi-Fi all through San Francisco. And he was basically just sort of like wooed by a couple of people at Google Earthlink and gave that project to them. Unfortunately, it was rather technically poor, and it was also politically executed in the fact that he sort of rammed this down most of the government's throat, and they sort of kicked back. When I saw it, I said, oh my God, this thing's a pile of crap, and so I actually fought against it and delayed it for quite a while there. But what happened is during this time is that Google or Mayor Newsom actually tried to put a proposition on the ballot to try to force the hand of most of the government to try to push this thing through. There was a resounding success that, yes, the public voted this thing in, and so he basically had to go forward with it somehow. But in the second here, during this time that we were noticing that this abomination called Google Earthlink Wireless was going forward, I discovered there was a bunch of fiber that was laying in the ground in San Francisco. And probably most people knew this already, but we didn't know the size and scale of it. It was an enormous amount of what the city of San Francisco had pulled in for other projects, what the city of San Francisco had basically gotten abandoned to them in place by, thank God, 2000, the dive on the financials during that time. So I was saying, gee, instead of using 802.11 to do backhaul to try to do this wireless stuff, why don't we start putting fiber into every single street address in San Francisco? The main reason is, and everybody knows this here, is that last mile cost is the big bottleneck at one point. When we started Little Garden, which was an ISP that I and a number of other people started back in 90 or so, something like that, we were paying Rick Adams about $5,000 to $6,000 a month for a T1's worth of bandwidth, and it was still costing us about $500 to get it to our place for the T1. So the transit costs at that point were about 95% of the costs. Now at this point, as you know, transit is in the single digits, but the last mile is still hundreds of dollars. So now the last mile is like 98% of the cost of getting bandwidth at your location. So this begat what I call the proposal. And so I and a number of other people, Matt Peterson being one of those people and such, crafted this sort of business model that we sent to the city of San Francisco during the RFC phase that they got forced into doing, because it was shown that they really didn't go through the proper process of handing this over to Earthlink. And what we did is we put a proposal to say, let's just work on the OSI layers and say, have the financials work the same way. This is much like you'd see any other layer 1, layer 2, layer 3 provider work on. But this is all new to the city of San Francisco. They haven't quite figured this thing out yet. So in the case, layer 1 would be the city of San Francisco. They would basically dig up the streets. They'd fuse the fiber. They know how to dig up streets. They do that really well. They putting them back together is another problem. The data link should be run by some sort of layer 2 provider, possibly a nonprofit or a not-for-profit. There's two different things there. And then the layer 3 provider is not touched by the city of San Francisco at all. That would be any Tom, Dick, or Harriet that would show up at a data center. So in essence, what happens is, as a resident or a business owner in the city of San Francisco, much like you would go to Looking Glass or some other fiber provider, you would say, I just need backhaul to 200 Paul, and I want to connect to some other layer 3 provider. So I, again, as a resident, say, gee, I'd like to connect to sonic.net. I call sonic.net. They said, oh, sure, yeah, we'll provide you bandwidth. And they put some sort of virtual private network or VLAN to my place and start selling it as bandwidth to me. And then they pay the city of San Francisco, the layer 2 provider, for that pipe. So again, I just described the money, how it flows down the stack. The problem is that we aren't just dealing with these 2 layers or these 3 layers. And this is a famous extended OSI stack, and this is the one I took a picture off of ISC's T-shirt. The problem is those 2 other layers, the financial and political, and that's the ones that get us in trying to deploy this sort of thing, as we had no money and we have politics in the city of San Francisco. So as I mentioned, I did a lot of activity to try to stop this thing. I went with the board of supervisors and said, this is the reason you shouldn't be doing Google Earth Link, and these are like privacy concerns, technical concerns, things like that. So finally when Google Earth Link sort of realized that they couldn't figure out how to do this, and they pulled out, they actually did a deployment in Philadelphia, and they finally pulled out and said, gee, we haven't quite figured out how to do this thing. Let's not do City of San Francisco. It's just going to be a pile of something that we would have to step into. They pulled out as anchor tenant. I get this call from the City of San Francisco, them saying, okay, you screwed us over, Tim. What do we do now? And I said, well, remember that proposal I sent to you? Why don't you start putting fiber into places like housing developments? You do a couple things with that. You address digital divide issues. You don't have to worry about an SLA right now. If the thing goes down and it's free, oh well. But you start getting sort of like gaining the expertise of what it's going to take to at least get these fiber into some of these buildings. And housing developments are probably a good start in that. And that actually makes good press as well. Well, apparently they took me seriously on that. So what happened is we ended up putting in fiber to about 40 plus housing developments, and I'll talk about that in a second here. But one thing is that in order to be able to do that, you obviously need switches, gear, things like that. We didn't have any funding to be able to do that, so that's the layer 8. Since there was no funding, we were expecting the funding to come from Google Earth Link for a lot of this stuff, and the city of San Francisco has always been one of those things that has run in the red. What they did is they hired this one guy by the name of Mike McCarthy to project manage it. Mike is actually an old friend. He's been working on other places with companies like One Economy and such to try to put fiber or at least bandwidth into housing developments in the past. So there was no money. So what we had to do is we had to sort of beg, borrow, steal a lot of this infrastructure to put it in. One of the creative ways to do this is there's an organization called TechSoup. TechSoup gets donations from Cisco. Cisco donates to them, and then TechSoup charges like 10% of what the retail cost is for a switch. We usually will have a nonprofit that follows in the appropriate conditions that Cisco or whoever else has for that gear. They'll buy the gear, they'll put it into a housing development, because the nonprofit usually will exist there for employment and helping and things like that. And then we manage the switch. So we actually built this whole thing with just switches and fiber for actually zero cost, or at least sunk costs that we already had with the city of San Francisco. So surplus fiber was supplied by the city. Monitoring, routing, and everything has been donated, and I'll get into that a little bit. And the technical labor has all been free as well. It's like Matt Peterson, Steve Gibbard's actually been helping out a little bit on this thing. In some cases, we actually did have a little bit of money. The San Francisco Housing Authority did actually, with new deployments, put in some decent copper infrastructure, almost. This is actually Cat 5 as opposed to Cat 6, so we can't run 1 gig on some of this stuff. But this is a typical install for some of the high-end installations we have at a housing development called Valencia Gardens. This is the main MDF. You can see in the back there the single mode that's going up to one of our Cisco 2960s. Again, really not high-end switches, but they work. And then these go off to a bunch of other 2960s and such as our access switches and such. This is a floor plan, so to speak, of all the buildings at Valencia Gardens. So I don't know if you can see it that well, but in the kind of the upper right-hand corner there, that's where that picture was taken. And then there's basically a sort of daisy chain of these little red lines, which are gig drops to each one of the buildings. And then, in theory, each person can just plug into their apartment unit and get 1 gig symmetrical. It's shared, but it's still pretty decent. This is an installation on the outside of one of those buildings. This is an access switch. Goes into a standard sort of Niemann box. In a lot of locations, we couldn't do fiber. And so what we've done is, I don't know if anybody knows San Francisco, there's a couple high hills there. There's a place called Sutro Tower, big tall tower, big spiky three things called antennas up there. And then there's a couple of antennas that are next to that place called Twin Peaks. And so what we've done is we put up standard sort of ubiquity sector antennas, and we get around 20 to 80 megs or so to each one of these sites through a backhaul. This is a site that's in the Castro district with the antenna, little nano bridge that's pointing up to not the big tall thing, but the antennas just to the left there on the horizon there. That's where Twin Peaks is. And this actually works pretty well. That actually goes to a little bit of a cheaper switch, so it's just a standard little Netgear because we only have like 3 access points. You can see the plug on the bottom, which goes to the nano bridge, and then the 3 other cables go to the access points. And so this is a relatively low-cost installation. This is a cacti map, a weather map of the deployment. This is almost all the fiber deployed. We have a ring, and then we have a bunch of laterals that we're trying to get back into the ring. There's about 90 switches out there on this network at this point. Because of that, we have a number of issues, which we're going to talk about in a second, too. Layer 1 issues are, obviously, as anybody knows about running fiber networks, that you're going to have cuts occasionally, and we do have cuts. The city tends to thinking that they're the only customer of this fiber, it just cuts willy-nilly, and then all of a sudden we'll have like a day outage. Even though we have a main ring, that still doesn't cover some of the laterals and such we have on there. So layer 2 issues, when they first started doing this, they basically just made this one gigantic VLAN. This is all on VLAN 1. So if anybody knows dealing with customers, that means that anybody plugging in their Comcast router, all of it all of a sudden becomes the main router for the network. Bad thing. So we've had to do things like turn on DHCP snooping, somehow isolate these customers from each other, and with zero cost. So none of these switches out there are layer 3 supporting. We've actually had to bring these things all back to a bunch of VLANs and bring them back to a couple I think it's OpenBSD routers that we have right now that are segmented out into a bunch of different VLANs. The other problems that we're running into is wireless has its own problems too. So for instance, Ubiquiti runs a sort of a pseudo mesh sort of thing called WDS. And what happens is we've seen those boxes out there actually start proxying and announce other MAC addresses on the network. And so if you run one gigantic VLAN out there, all of a sudden a tiny little Ubiquiti router or radio out there is now announcing the MAC address for your main routers. So all of a sudden traffic starts going back to some other box that's way out on the edge there. This is all not good. Of course, spanning tree has its own problems. Trying to tune something with this large of a network is a problem. We've had a tweak on that. I'm not going to go cover that too much. Everybody knows problems with spanning tree. So how do we do this without spending a lot of bucks on layer 3 enabled switches and such? So we've had to segment a lot of this stuff out. We're starting to segment a lot of this stuff out by basically putting in IP routing. Some of these are like microtick boxes. Some of these are, we're actually getting some layer 3 switches out there. A lot of like little SOCRIS boxes and things like that. And this doesn't scale too much, but we're learning. So here's an example of this. So if there's any vendors out there that would like to sort of show up a microtick, we'd love to talk to you. It's pretty easy. So layer 3, the goal on this is not so much to be a sort of a community network per se, but we actually want to make this sustainable. We want to make this a commercial network, as I said earlier. Doing the nonprofit, the housing developments and such was basically a way to get our toe in the water and get some ideas on this. So let's see, I'm going to skip that one. Oh, okay. Actually, I was jumping ahead, sorry. So layer 3 was basically the fact that we're having problems with Internet Archive uptime and such, who's just supplying the bandwidth. Layer 4 through 7 problems are basically customer support. So if you get into housing developments, you're usually getting into folks that have rather crufty and old laptops and things like that. So you need some sort of customer support on this thing. And anybody who runs an ISP knows, especially during the days of the old trumpet windsock and things like that, is what it takes to sort of like support customers on old crufty laptops and platforms and such. So we're engaging other organizations like City College has their own technical tech sort of track that we're training those people up to have them try to come in and take over and sort of run around housing developments and give support on this. The end result is the work actually started with fiber deployment in early 2008. San Francisco Housing Authority spent around $250,000 on mainly radios that we could put on at these locations, as well as some of that wiring that you saw. So actually, in a lot of those housing developments, we'll have radios up, and then neighbors can actually plug in and connect. So I have a number of folks that actually have like little nano bridges and connect to the housing development and get free bandwidth that way. We finished up lighting the 40 housing developments in San Francisco. This consists of around 6,000 units or around 15,000 customers. Of course, not all 15,000 customers are plugged in at the same time, but we do see probably around 1,000 or 2,000 customers usually connected simultaneously. User access is, they can connect anywhere between 10 to maybe 1,000 megabits. We normally, I don't know if I didn't show you one of the traffic graphs, but we usually are pushing around 200 megs or so on this network. Let's see. Oh, one of the other things that we're doing is we showed you that Twin Peaks installation. We're really interested in trying to get as much free net out there as possible for the city of San Francisco. And so we're actually talking to, this guy, Ralph Mullen, who is actually pretty good about configuring these rocket and nano bridges from Ubiquity. What we want him to do is basically you pay $60 for a rocket dish. You go someplace, you plug it in, it auto configures, and then you can take this to your neighborhood and then set it up on your rooftop. And then there's a number of mesh protocols that we're looking at to sort of light up the neighborhood at maybe like 10 megabits or so. In addition to the housing, CBN is supporting a number of nonprofits, and I just want to mention that these are the people that actually we're having to get a little more serious about making sure that we have uptime. Academy of Sciences, a couple of years ago I talked about how we did fiber or a wireless network out to the Farallons, and that's the folks that actually are getting supported by that. Point Reyes Burbs are returning the Farallon Islands. Bay Area Video Coalition, they are the folks that run the kind of like the nonprofit or public access for the cable channel. Mission Economic Development Agency, Boys and Girls Club, Gary Air Foundation for the Arts. These are a number of nonprofits. So where does it go for the future for us? We have lost some steam. At one point in time, there was a lot of direction by Mayor Newsom for this thing. He's now Lieutenant Governor. We had a guy named Chris Veen who was the CIO for the city of San Francisco. He's now at the White House. Those are the two go-to guys that actually said, let's get this thing done. With them leaving, we actually lost a little bit of direction, and we needed some rudder on that. There's a guy named John Walton who is our new CIO, and he's taking more of the reins to be able to have it happen. Really, the only way that you can get these sort of projects done through this sort of grassroots means or any means is you have to have somebody at the mayor's office or at least the supervisor's level to be able to say, this is my project and I'm going to push this thing through. Everybody else just sort of follows suit of whatever the wind is blowing at this point. And for about a year or so after Chris and Mayor Newsom left, we were kind of running around trying to figure out how to get that direction. So the other problems we ran into is the fact that most city governments are not designed to sell resources and such. In fact, the fiber installation and the copper assets were specifically set so that they could not be resold to customers. And then we just recently, as in actually about 6 to 8 months ago, got some rules passed so we can actually start reselling at this point. And in fact, Robert Chu, as one of the Board of Supervisors, has announced that we're officially starting to do that. To this, there's two sides to this. As I mentioned, there's the kind of the nonprofit side, which is the side that's supporting the housing developments and the nonprofits and such, and we want to make this sustainable. The non-commercial side, we're going to be creating. In fact, we're in the middle of incorporation at this point. In fact, Steve is kind of giving us some pointers on this because of NANOG, to create a nonprofit called the Community Broadband Network, which will be effectively the ISP in running this network for the city of San Francisco. The city is starting to go into the commercial side of things. In fact, right now we have 3 commercial companies, so to speak. We have UCSF, which is one of the, it's a main hospital for the city of San Francisco, which has campuses all over the place. They're buying dark fiber. America's Cup is going to be coming in next year, I think 2013. They're going to be taking up all the Embarcadero pier space, and we're going to be providing fiber to that, kind of a big piering fabric or fabric between all the piers, as well as it goes all the way back to 200 Paul. And then we're also, as I mentioned, Sutro Tower, we're putting in fiber into there. That's going to be a big sort of media fabric where we're going to be hooking up the 9 TV stations and the 5 FM stations that are up at that location, and then bringing that back to hopefully cross-connect to people who actually produce content so that they can push stuff back, as well as going back to their studios for their studio transmitter links. The couple other things I wanted to mention is that the fact that in the future is that we're continuing to expand on the wireless. I mentioned that we got approval for Sutro Tower. We're just turning up all the fire departments at this point. We see them as great hardened sites. They usually have a lot of hardened infrastructure because these things have to stay up when emergencies. So we're going to be home running as well as creating some rings to all of the fire departments. And those are going to be the locations we're going to be putting radios for emergency communications in case we have another 1989 earthquake. We're going to be turning up 6 to 7 library sites in the next 6 months for free wireless. This is also going to be used for backhaul for Wi-Fi in the city parks, and will be a test bed for the new National Science Foundation Ignite project that just got announced. Will be one of the test beds for that. If folks don't know about that, that's a project that's with Mozilla Foundation as well to try to figure out what you do with 1 gigabit when you get it. So one of the examples is, like, I don't know if anybody's played with the Internet Archive. They have kind of a book application, which is, it gives you kind of a really sort of like real time and real feel of flipping through a book that they've digitized. But it requires quite a bit of bandwidth because there's a lot of graphics that goes back and forth between the Internet Archive and the application. And to the end, I'm also looking for people that actually are interested in helping out on this project.